Hi everyone, hello Unity community. We are, oh my God, I'm so excited to be here with you today. Let's actually kick off this awesome live stream. My name is Esteban Maldonado. I am a developer advocate at Unity. And, what our team does is that we actually go and visit different communities around the world, thankfully, or sometimes online, like what we're doing here. And we spread the word of, you know, new and upcoming Unity features. So I'm gonna be your host for today for this awesome live stream, which I am very nerdly excited for. I You're all here for visual effects, and we're gonna be going a little bit deeper into shader graph as we've done multiple live streams before. So. Yeah, before we get started with that, I definitely want to say hi to the community. I want to say hi to a couple of users that they're very legit ride or die. Like, gotta say hi to the bull, Mr. Awesome, Marcos Araujo. I gotta say hi to Unimal, Fredo. Oh my God, like people that were logged in here like even before the stream started. So thank you very much for being here, and that's amazing. So we're live on Twitch and YouTube right now. Yeah, so but I think that we can actually like start proceeding into what we want to what we want to check out, and right. So I will say though, I'm kind of curious if y'all like could actually like start putting on the chat. I would like to see like where are you all from? Like where are you logging in from? Like would be awesome. Like I am right now in Seattle, Washington, although I am originally from Puerto Rico. So super happy to be here. So where's everybody? Is everybody logging in from? Like, I'd love to hear from you as well. I know some already. Mr. Awesome, the house, New York to the Bull. So the Bull, I know you're joining in from New York. Mr. Awesome is from Alabama. Alabama, shout out to Alabama. Indonesia, Uzbekistan, I already see. France, and definitely from Guadalupe. From Guadalupe. Oh my God, that's amazing. Already getting some love. So people getting pretty excited for Shadergraph. I see California now, Canada. That is amazing. So thank you all for South Africa as well. Oh wow, that is super. That is super awesome to know as well. So we are definitely multi country live stream, multi continent live stream as well. So everyone's welcome here, and we all know that shaders and and imitating life itself is like it's an amazing topic of like using math for these very visual result, this very beautiful result as well. So so before we actually get to the content, one last thing, a little bit of housekeeping notes. And Jack, can you actually help me out here with that Unite slide? So gotta give a shout out to Unite 2025. Another reminder that it is gonna be happening in Barcelona in Spain from November 19th to the 20th. So if you're able to join us, please it'll be an awesome event full of lots of updates about Unity technology. Be able to connect with a lot of fellow Unity users. So if you can make it there, feel free to reach out and have an awesome time while also learning about the new updates of Unity. So yes, but I think that was the basically the only housekeeping rules that we got at the moment. So Jack, I think that we're ready to bring in our awesome guest that I think he's coming in here for the fourth time or fifth time, I believe, but he's always awesome. So, Unity community, let's give a warm welcome to Ben Cloward. There you go.
Hey, hey,
There.
Esteban. Great to be on the show. Thanks for having me.
No, like amazing to be doing this episode with you. Not gonna lie, as soon as I was told like, hey, you want to help out with this live stream about graph, and like before they could finish saying shader graph, I was like, let's work, let's make it happen. I not only have I seen I saw one of the previous live streams that you did before with us with Jackson. Um, Ben, I've seen some of your YouTube videos because not only are you here to share your knowledge, not just that. Not only do you work at Unity as a staff technical artist, not only are you heavily involved in the development of Shader Graph itself, and the actual samples that are included with the package, but you also have a YouTube channel where you give shader advice in both Unity and Unreal. And do you cover Godot as well, or
Nope.
no?
Just Unity and Unreal. Yep.
Okay, but still, that's amazing that like you're doing this amazing content for both, like for these two awesome engines. If anybody in the chat, this is a Unity live stream, but if you have a friend that would like to learn more about making shaders with Unreal, definitely please share Ben's channel. Like amazing resource. So Ben, like for those of you who may not have seen the previous live stream or may not know a little bit of your about your work, like can you tell us a little bit about yourself? You know what do you do at Unity?
Yeah, so I've been at Unity a little over 4 years, and I work for the shader graph team. So we're helping to develop the shader graph tool, doing active development on the tool itself, as well as creating sample content to help people learn how to use shader graph. Before I joined Unity, I worked for about 14 years for BioWare, and my career in the video game industry goes back all the way. I started in making games for the PlayStation 1 in 1999. So I've been around the block a few times.
Whoa, wow. Like 1990. Oh, wow, that's amazing. Like, so you definitely got a lot of wealth of knowledge with you that you brought in from different, different pastime, different projects over to Unity. So
Yeah.
like amazing to have you. And somebody has tried shader graph a little bit here and there over the years, and I've seen it grow. Like, dang, like honestly, like you and the team do amazing work. So
Thank you.
uh,
Appreciate it.
that's amazing. And in fact, Ben, like, what are like just maybe a little top of your head, because we were talking about before the stream started. Like, what are some of the cool updates from shader graphing 6.3? Which yes,
Yeah, great question. So there may be a few people on the stream that haven't heard of Shader Graph. If so, Shader Graph is Unity's node-based shader editor, and generally shaders are written in code. But Shader Graph is a tool that makes shader creation visual, and it empowers artists and designers with no coding experience to define the visual style of their projects and also to create stunning real-time effects. And we're going to take a look at some of those today. Now, Unity 6.3, our upcoming release, is currently in beta, and it's Shader Graph's biggest release since we launched the project back in 2018. We've been showing off some of the new features over the past couple of weeks, and in fact, in the previous 2 live streams that we did, we showed off new features of Shader Graph that are coming out in Unity 6.3. But even 2 live streams wasn't enough to cover all the cool new features that we're introducing for 6.3. And I'll just kind of, I don't have a lot to show here, but I just kind of want to run down a list of some of the new things we're introducing. So previously, we only had supports for using 4 sets of UV texture coordinates rather. And now in 6.3, we're introducing up to 8 sets of texture coordinates that you can use in Shader Graph. We are also exposing keywords and parameters so that inside of subgraphs, you can expose those keywords and parameters to the material so that you can have nested subgraphs, but expose those parameters to the main graph material without having to plumb them all the way through. It's a really nice quality of life and organizational feature. We also have custom interpolation between the vertex and the pixel shaders. And in Unity 6.3, we're introducing a couple of new options for that interpolation. Instead of just linearly interpolating data from the vertex to the pixel shader, you can now turn off that interpolation if you want to not interpolate, or you can turn off perspective correction to kind of imitate the way that games used to look like on the PlayStation 1, for example.
oh,
Yeah.
okay.
We're also introducing a brand new template browser as a way to speed up the workflow and allow you to jump in more quickly to shader creation. In the past, when you've selected to create a new shader, you'd start out with a completely blank canvas. But now in Unity 6.3, we have a browser that you can select from a long list of templates. You can pick a template that is similar to something that you might want to start doing, and then kind of work from there, starting with a nice, a graph that's already created, and alter that instead of just starting from scratch. So we're hoping that the template browser will be a really nice boost to people's productivity in shader graph. And it's even possible to define your own templates. So if you have special requirements for shaders on your project, you can create templates for those, then give them to your team, and then all of the shaders that your team creates can be based on those templates that you created. And in addition to that, we're still going. We have support for terrain shaders in 6.3. Previously, you could make terrain shaders, but it was kind of a hacky process, and now we're officially supporting shader creation for terrain with Shader Graph. We're also introducing shader support for UI Toolkit. So in UI Toolkit, when you create user interface elements, you can adjust their appearance and their shape and their style and their movement with shaders in Shader Graph. And we've also introduced a new set of sample content that helps users to create custom lighting in Shader Graph. So if you want to adjust the way the lighting works to make it cheaper, if you're on like low-end mobile devices or XR platforms, for example, you can make the lighting cheaper by creating it yourself in Shader Graph. Or if you want to stylize your lighting and make your scene look like it's created with oil paints or watercolors or toon shading, for example, you can do all of that in Shader Graph as well. And this new sample content shows people how to do that. So there's my list.
Oh, wow.
we made it. It's huge. 6.3 is going to be a great release for us.
That is an amazing list. And in fact, if I'm not mistaken, and this is the last question before we dive into your demo, which like I'm quite excited. I got a little bit of preview. I haven't seen the whole thing, but Ben showed me a little bit of his goals, and like, oh, it's gonna be so good. I'm excited. But Ben, you did cover very briefly. You did cover in a previous live stream the custom lighting, if I'm not mistaken, correct? There we go. So, folks, like search on the YouTube channel, like custom lighting, and there's a live stream dedicated to that topic. Like Ben mentioned, if you wanted to like stylize or light your scene in a more particular way instead of like the traditional realistic simulation kind of lighting. But okay, but with that, let's actually start off. And I see that we first have volumetric effects. So Jack, let's see if we can get Oh, I love this part. Okay, Ben, what are we looking at here? Like, what are we looking at?
Yeah, so just to kind of introduce the topic, one of the core things that Shader Graph does is it helps you to take complexity and simplify it so we're able to imitate that complexity in real time. And that's the theme of our stream today. So one really good example that most people be familiar with is normal mapping. So if you have a very simple shape and you put a normal map on it, it makes it look like there's a lot of surface complexity when in actuality, it's just a cube or a sphere, but it looks really detailed. And so what we're going to be talking about today is several ways of imitating the appearance of complexity when that complexity actually doesn't exist. It's an illusion. And the world is filled with these kinds of like really complex phenomenon. So what we're looking at here is a block of ice. I filled up a cooler. I stuck it in the freezer for a couple of days. And here, let me just hit play on this so we can take a look at what we're looking at here. So this is ice, and it's filled with like lots of little teeny tiny air bubbles. And as we kind of move the camera around, you can see that the interior of this thing is just like infinitely complex. And creating this kind of an effect with just modeling would be a nightmare to like make all of these little air bubbles and things. But what we're going to be doing today in Shader Graph is creating a volumetric effect that makes it look like there's tons of detail inside the interior of an object when it's not actually there.
And just to clarify, sorry, just to clarify, like for folks that are maybe just joining, this is not the visual effect. This is a real thing.
Yeah, this is a video.
Like it would be that awesome, but this is like your inspiration from real life.
Yeah, that's right. And I do want to stress this. It's really important when you're trying to imitate something, you need to go out and look at it like the real thing and capture like what does the reality look like. And then you can take your reference that you've created, like this video that I'm showing here, and kind of break down and say, well, it has these particular elements, and those are the specific things that I'm going to try to get my shader to do. So in this case, we're going to be trying to imitate that appearance that the surface has an interior and that there's some volumetrics happening there.
Nice.
So we ready to jump in?
Yes, I'm
all
so
right.
excited.
All right. So what I have here is just a regular cube, and it has this kind of noisy texture on it. And right now, the way that our texture is set up, it's just using like standard UV coordinates. So here are my UV coordinates. They're just being used by default. And so it makes it look like that texture is stuck to the surface. But what we want to do is make it look like this object has an interior or a volume. And the way that we're going to do that is by offsetting the UV coordinates based on the view angle or the direction that I'm looking at the surface. So what I'm going to do is add a camera node. And this camera node has all of these different properties of the camera, including the direction. And so I'm going to take that camera direction and I'm going to transform it from world space into tangent space. And it's a direction, so I'm going to set the type to direction. So I'm going from world to tangent. And the reason that I'm going from world space to tangent space is my texture coordinates on the surface of my model are in tangent space. So I need to get data that's in that space.
So, and when you say direction, Ben, like I assume you mean like where the camera is looking at.
Is pointing. Yeah, that's exactly right. That's exactly
awesome.
right. Okay, so I'm going to take my camera direction, transform it to tangent space, and then I'm going to split it so that we're only taking a look at the X and the Y components of that vector. So I need to add a split node. Go ahead.
Hey Ben, real quick, so transforming this tangent space, like how would you how do you feel like, or how do you explain to people like when they want to understand what is like tangent space and like getting it from world to tangent?
Yep. So what we're talking about is what is zero, or what are we relative to? In world space, there's a specific point in the world that is our 0, 0, 0 point. And so when a vector is in world space, everything is relative to that particular point in the world. In tangent space, there's a 0, 0, 0 point that's like the corner of our UV coordinate plane. So if you unwrap your model and you have your UV coordinates, the 0, 0, 0 point, our coordinates are relative to that point on the surface of the model. So we've transformed our vector. So instead of being relative to 0, 0, 0 in world, now we're relative to 0, 0, 0 in the UV coordinate space.
I see, in the more 2D,
that's right,
2D world of the texture that is wrapping around the object.
Yeah.
That's cool. Thank you very much.
Yeah. Okay. So we're going to take our vector here, and I'm going to add a reflection node because we want to reflect inside the ice and use the direction that we're looking to offset our UV coordinates. And just for now, we're going to reflect around the the 001 normal, which is basically like the flat surface of the object. And then we're going to split what we've done here and just take the X and the Y components. And I'm going to take those X and Y components and we're going to add them to our UV coordinates. So we're offsetting our UV coordinates based on the direction that we're looking. And then I'm going to pass those coordinates into our texture and I'll save. Now we're going to get an updated shader here. And instead of the texture being stuck on the surface,
Oh, look at
now,
that. Now the texture is adjusting to where you're looking at because you fed the direction and you converted it from world space to tangent, which is the 2D. And now it's sort of like it's sort of like it feels like the texture is looking at me. Like very, very weirdly, very
it's as if the cube is made out of glass and we're looking through the glass into the texture instead of the texture being stuck on the surface.
that is awesome.
So that is the core of the effect. But right now it's a little bit too strong. We want to make sure, like right now, it looks like the object is infinitely deep, but we want to add a little bit more to our graph so that we can control it so that it just offsets like a little bit instead of like this much. So yeah, we have too much offset right now and we want to control it a little bit so that it's not offsetting quite as much.
The Heshang, I hope Heshang. Sorry if I'm pronouncing your name or the username wrong, but mentioned the portal. Like felt like it immediately thought to portal, and I was like, yes. I kind of got that portal feeling. Like, oh wow, that's so. There you go, folks. This is a little bit of how you can get started if you want to make that kind of effect. But sorry, Ben, please go on.
Yeah, so we need to tone this down a little bit, and what I'm going to do is we calculated this reflection vector, and I'm going to take the Z component that we're not using yet and add an absolute node. An absolute will take a value that is either negative or positive and make it so it's always positive. That's what absolute does. And then we're going to add divide. And remember, our goal here is to tone this down so it's not quite as strong. So we're going to divide this by a value, and this is the value here that we're going to use to control the effect. And in this case, I've already played around with it a little bit, and so I know that 1500 is a good value to add here. And then once we take that value, now we can just take, let's see, I'm just going to scoot these nodes over just a little bit to give us more room. I'm just going to take these two and multiply them. Go ahead. You have a question?
Sorry, my bad. And that number, the 1500, did you have any particular reason or just no particular meaning whatsoever?
I'm going to get to that in a minute. What it actually is like the number of pixels that we're offsetting the texture.
Okay. So I got a little bit ahead of myself. And by the way, I'm going to
okay.
take this opportunity. Thank you, Jack, for the note. But yes, folks, if you have any questions for Ben, feel free to write them in the chat as Ben delivers his presentation. And eventually, near the end or a little bit in the middle, if you find a break, we can get some of those questions. But yes, we'll try to answer them in the chat as well. But cool, Ben. Please go on. This is amazing.
Okay. And then the other thing that we need to do is multiply by the size of our texture. And so in shader graph, that's really easy to do because I could just bring in our texture size node here. And I have the texel width and texel height. That's the size of the pixels in the texture. And so I'm just going to use a vector 2 node here to make this into a vector 2. So I have my texel width and texel height, and I'm going to multiply our effect by that. And then pass that in, and we're going to add that to our UV coordinates. So now when I save this, what you're going to see is we still have that same parallaxing effect. Oh, I think I did something wrong. Let me double check my math here really quick, because now our effect is like really strong, and I actually intended it to be a little bit weaker. So let's see what this looks like.
It's okay.
Okay. Yeah, so now we've toned it down just a little bit. So now instead of it being like infinitely deep, it's just like a little bit deep.
Oh wow! So now you have now you have some control over how strong the effect is, and you could even
Yeah.
expose this
And
as
I
a
actually,
variable if you want it.
yeah, I actually found the mistake that I made. I intended to, there we go. Let's see. Yeah, I intended to divide like this. There we go. Okay, so I'll do 1500 here. Yeah. Okay.
Right?
So now that we've got a little bit more control over this, there are a couple of additional things that we can do to make this more interesting. Right now, we have an object that we're kind of peering into, and we have a surface. Like, can you see the reflection on the surface right here? That's kind of a neat effect.
Oh,
But the reflection is like perfectly, the surface is perfectly smooth.
I see.
And
Like what I'm looking through. Look, when I can see what I'm looking through, it's perfectly uh, perfect. You're saying?
right. And if we remember that video that we looked at the beginning, the surface of the ice, there was a really interesting interior shape of the ice, but the
Yeah.
surface was also kind of rough looking.
Oh, so
And
I see. So you want so the ice, if you were to look at something through the ice, it would come out distorted. You know, like the reflection would come out distorted
right.
and all messed up. So you well, not messed up, but just distorted. But now, so now, like you want to imitate that effect from real life into your effect.
Yeah. So I can take this normal map here, which is just kind of it's mostly flat, but there are little imperfections in it.
Okay,
And I'm going to use this instead of, so our reflection vector here, right now it's using 0, 0, 1, which is a flat normal.
exactly.
And instead of that, I can take this normal map, which is just kind of bumpy looking, and plug that in instead. And now when we take a look at our surface, now we have a surface that is kind of messed up looking instead of being perfectly flat. It's
Oh,
imperfect. And this effect is on the surface, and that noise is actually offset from the surface. And so we get this really nice like imitation of depth here where we're looking through the surface, and the surface is kind of rough looking, but we have that cool looking
oh wow!
interior for the ice as well.
It's starting to feel like it's cold, like it's cold and frozen. Like that is super cool from where we started and where we're at the moment.
Yeah, and we can control how much depth there is using this value right here. So I'm going to plug this value in like this, and I'm going to add one more texture. In this case, what we want to do is instead of like right now, when I move this around, there is an interior, but it's all like at exactly the same depth.
Oh, I see.
So it looks like there's a flat plane inside it. And what we want to do is change the depth so that each pixel has a different depth offset. So right now we're just using a hard-coded value for that. But I can take that same noise texture that I'm using and use the black and white value to offset the depth amount so that instead of a constant value for the depth offset, we have a different value for every pixel.
And are you? I mean, and you're not actually like offsetting in terms of world space, like more like the illusion, right? Right?
It is an illusion because we're offsetting the UV coordinates of the texture
Oh, that is so cool.
and not actually, yeah.
Wow.
Okay, so I'm going to set this to 1500. So this value here, this noise is between 0 and 1. And I'm going to multiply it by 1500. So now it's between 0 and 1500. And what we're doing is offsetting the UVs somewhere between 0 and 1500 pixels. And we'll end up with something like, you know what? I have made a mistake
That's okay.
somewhere in here. I
Um,
bet you one of the viewers will point it out to me. They're like, "You're so dumb. Why are you doing that?"
no. Yeah, yeah. Especially, yeah. Well, the community is very supportive, and especially, we're not gonna say that to the person that has like the actual data collected of all the stuff of his actual tutorials. There we go. He fixed it up live and in a couple seconds.
Yeah.
Oh,
So
wow.
right now it's like really deep. So let me see if I can
And Ben, right now,
change
like
his
if
value
somebody
around a little
wanted
bit.
to, the main benefit here is like, yes, it is like an illusion, but if somebody wanted to model, if somebody wanted to bring in an actual model with all these details, they would actually need to like carve out, like, or make it look like this at the model level. Whereas here, you took a regular cube with a plain texture and made it look like this volumetric ice.
Yeah. So I've got what I was looking for now. So if we look, you could see like there are different amounts of offset here based on the value of this noise texture. So where it's white, it's being offset the most, and where it's black, it's being offset just a little bit. And
By
we
the
end up with this cool looking effect.
By the way, Ben, Mr. Robson said, "You got this, Ben." So,
Thank
community supporting. There you go. I love this community.
Cool. Okay, now obviously we could take this further. There are a lot of things that we can do with this, but what I wanted to do is kind of show you the core of the idea, where we are offsetting UV coordinates using the direction the camera is facing. So the texture is kind of parallaxing inside the object as we move around.
And also,
So
we got another sample that you're going to show us later on as well.
yeah, we'll get to that in just a second. But
Exactly.
what I wanted to do is kind of show you what happens if you whoops. What I wanted to do is show you what happens if you take this a little bit further. So I showed the idea, like the core of the effect, but if you work on this a little bit more, you can end up with something that looks like this.
Oh wow.
And what we have here is several different layers of offsetting. This effect was created by one of our other technical artists. Her name is Tracy. And we included it in the production ready shaders sample that you can download. One of the things that I said a lot with Jackson is we have a really, really well kept secret at Unity, and that is, and nobody will ever know about this. If you come up here under Window and go to Package Management, Package Manager, it brings up the package manager. And then if you select the shader graph package and pick samples, we have a huge list over here of sample content that people can download. And nobody will ever know because it's hidden away in the package manager, right? But if you download production ready shaders, this ice sample is part of that. And it includes a subgraph that does that parallax offsetting effect that we're seeing here. So if you want to grab that and pull it apart and play with it, you can.
Or even use it for your games.
Yeah,
Like,
absolutely.
dang, that is very cool. So go Tracy. Like,
yeah, no, she did a great job. Before we jump over and talk about the other sample, do we have any questions that people ask in chat?
Yes, and the bull actually asked, "Can you add something like a logarithmic curve to that offset?"
Yes, I suppose you could. Right now, we're just using like between 0 and 1 for this texture. and then multiplying it by 10. But if you added a power node here, you could adjust the curve so that the brighter values offset like on a like an exponential or logarithmic curve instead of a linear one like we're doing now. Yeah, sure.
And Angelina, sorry if I'm mispronouncing your username, but it mentions it's sort of like a comment, but also kind of like a question included. I think shaders can distort vertices / move them, but your cube will need a bunch of loop cuts. So, do you confirm this statement?
Yeah, absolutely. And that's kind of the point of the effect that we're showing here. The idea is we want to imitate complexity without adding complexity. The idea is we have a very simple object and we're able to make something without a ton of vertices, but still get this interior parallax movement. That's what the shader enables us to do. So we do a little bit of math here, which is actually it's fairly cheap, but we end up with something that looks, very complicated. Like there's a lot going on inside when there's really not.
And no, that's also, and of course we are testing on a cube, because it's a very simple shape. Other folks have similar questions, like what can you do, to deform the cube, or do I have to do it at the model stage? Which, if I'm not mistaken, yes, you can take advantage. Like, I forget, do we expose the geometry stage of the pipeline so that people can add vertices or like deform and construct stuff, or no?
So Unity is not really a modeling package,
Yeah.
but if you wanted to create your own object, obviously that looked a lot more like ice than my sample cube here. Absolutely, and you can apply this effect to an object that's significantly more complicated that looks more like ice than my simple example.
Okay. So even though we are showing the effect on the cube, you can apply it to other shapes as well, and try to see what kind of cool effects you get.
Right.
That's
right.
That's awesome. And let's see if there's any any additional questions. And Divina mentions, thanks for the reminder about the samples packages. Yes, I definitely agree. So, and I guess the last question that I see at the moment for now is like, can you use the reflection probe node? Well, Ben, he did use a reflection node for this to happen. Can you use the reflection probe node in Forward Plus? That is a question from Krugisa or Krugisa. Sorry if I'm mispronouncing your username.
Yes, the answer is yes.
Nice.
That's kind of off topic, though. We could get into that quite a bit, but it's not what we're talking about today. So
Okay.
I'll just leave it at yes.
That's fair enough.
All right.
Cool. So okay. So now, Ben, I think that with that we are ready for our next demo, which I see here is animated leaves. So, oof.
Yeah. So
these cubes to trees. That's gonna be amazing.
That's right. So foliage is another one of those areas where we see infinite complexity and we have to figure out how to simplify it. So I actually have another video that we could take a look at here just to kind of illustrate this point. This is a aspen forest, and I live in Utah. And so just like within 20 minutes of my house up in the mountains, there's this beautiful aspen grove. And, you look up into the trees, and this is what I see. I see like millions of leaves, each individually animated. And there's just like this infinite complexity. And, as a normal person, you look at this and you're like, oh, that's beautiful. But as a game developer, you're just like, oh my goodness, how am I ever going to imitate that kind of complexity and have anything more than like 2 frames a second on my game? You know what I mean? So, we have to figure out a way of breaking this down and enabling this kind of complexity without a ton of cost. And so that's what I'm going to show you today. So this kind of the video that we're seeing here is the goal. So let's take a look at our scene. Go ahead.
And I will say, for those folks, like some of the effects, like here, like it might be affected because we are watching and we are streaming. So, for example, there was a little bit of choppiness in the video, but of course, uh, I assume, Ben, that the video looks much more fluid, like when you look at it locally.
Yeah.
Yeah.
Sorry about that. Okay,
No,
so
not at all.
so
Not
the
at all.
first thing that we can do to kind of help tackle this complexity is, instead of modeling individual leaves, we can build this like full branch with all the leaves and everything and bake them to a texture. And so here we have a texture that has dozens of leaves and the branch all modeled into a single texture. And then we can apply this texture to just a single polygon. So that's what we have in our scene here. We just have this single quad object that I've mapped my polygon to, or that I've mapped my shader to. And so we've taken what could be, you know, thousands or even millions of polygons and reduced it to a single polygon just by, you know, baking all of that detail down to one object. So that's the first thing that you can do to kind of simplify. But once you're just on a single polygon, you've kind of limited yourself in terms of animation, because if you want to move these vertices around, there are only 4 vertices on my polygon, and so my movement is going to be fairly limited.
It's like moving a piece of paper. That's like,
Yeah, that's exactly right. Yeah. And so what I want to do here is show you like this before video. So here's an example of a tree that is made out of these polygons that I've mapped this texture to. And you can see there's a little bit of movement here, but it's not very dynamic, and it doesn't really have that same amount of like complexity that we saw in the original video looking up into the canopy of the aspen grove. So what we're going to do now is I'm going to show you how to animate these individual leaves in a shader.
so right now it looks interesting, but yes, not only everything, like all the branches are moving uniformly, like as
Yeah,
if somebody was holding them in a clear paper and sort of like waving them around. So
right.
not there yet.
Right. So we're going to start out with just our simple leaf texture here. And what we want to do is come up with a way of animating like individual leaves or clumps of leaves instead of the whole polygon animating. And so the first thing that I'm going to do is create a mask. And this mask is pretty easy to make. I can just take my leaf texture into a paint program and paint little red, green, and blue blobs based on the position of those leaves. And so let me find my texture here really quick. Yes, I just needed to remind myself what it was called. It's called leaf mask. And so there's my texture. And if we take a look here, you can see this texture doesn't have to be high resolution at all. You can see mine is 64 by 64. So it doesn't require a whole lot of detail. You know, you can just create this leaf texture with these red, green, and blue blobs, and it can be really low resolution.
I see. So is this kind of like a mask to sort of like mimic the shape of the branch itself?
That's right. So I just brought this texture into my paint program, and then I painted red, green, and blue on the individual leaves. And what I'm doing is creating a mask that will isolate, you know, this leaf from that leaf. And then I can add the motion, and those individual masked areas will have their own unique movement.
Oh, I see. And I don't want to jump the gun, but in my head, I have a reason as to why they're colored in this way. But I'll see. I'll let you explain why those colors specifically.
Okay. When we create animated effects, we need to bring in time. So I'm going to add in a time node. And in just a minute, I'm going to multiply my time so that I can kind of control how much of the movement is happening. But first, I'm going to add a sine wave here. And if we look at what the sine wave is doing, time is a value that increments and just continues to go up and up and up And if I add a sine wave to it, what it's going to do is oscillate that time value between -1 and 1. So instead of just infinitely incrementing, now I have kind of like a wave shape. And you can see that here as it's going black, and then it goes white, and then it goes black. And I'm going to use that to control the movement of my leaves. So here I'm going to take my mask texture, and I'm going to multiply it by my sine wave. So there's my mask. Here's my sine wave. And now I'm going to split out the mask texture into its individual channels. So I need to take the red, the green, and the blue individually.
And it makes sense why the texture is no longer showing up, and sometimes shows up because it's the color values are oscillating with the sine wave at the moment.
Yeah. So I'm going to split out my red, green, and blue, and then I'm going to add them back together. And this is going to make more sense in a moment. Right now, they're all just kind of one big thing. But in a minute, we're going to change the time values so that each of these masks gets unique values. And now I can take my UV coordinates, and I can add my values here that I'm calculating to the UV coordinates. So I'm going to take my UVs and add my masks to them. And then we're going to pass that in. And this is going to look really nutty for a minute because the offsets that I'm assigning are like really, really strong. So you can see that I have those leaf sections in there, but they're like offsetting a lot.
Oh wow! So you're so you're messing with the UV coordinates, the coordinates that are used to sample what color to apply to a particular pixel, and you're oscillating and you're messing with the coordinates.
Yeah, that's right. So now what I need to do is I need to make it so that each of those masks, the red mask, the green mask, and the blue mask, get offset by a different distance and a different time.
Okay.
So the first thing that I'm going to do is take my time that I have here, and I'm going to assign different values to the 3 different channels. And that's pretty easy to do. I can just multiply time by a vector 3. So if I add a vector 3 here, now I can just give 3 different multipliers. And these are numbers that I figured out beforehand, but these are things that you can kind of tune to be the way that you want them to be. So I'm going to multiply by 5.6, 6.66, and then -5.2. And instead of one solid time value, now I have 3 different time channels because I've multiplied by vector 3.
Oh, I see. So you have, in a way, sort of like three different kind of distortion values, time values for distortion, for different distortion effects.
Yeah. So now what we have here, and you can see this happening with our sine wave, it's showing up as different colors because I have 3 different channels that are doing the sine wave at different times.
Oh.
So it's showing up as like red, green, blue, purple, cyan, that kind of stuff. But actually, it's 3 different channels.
And they're oscillating at different wavelengths. So that's why you get kind of like this mixy effect sometimes. It's sort of like disco if you replicate it. Nice. And I even see that since you're applying that effect, even the mask is now oscillating. Each of those channels are oscillating at different wavelength. At different times.
Yeah, so I've separated out the red, the green, and the blue, and then when we add them back together, now we get this effect of them going off at different times. So if we save this now, you're going to see. So my effect is still too strong. And the next thing that I need to do is take the result of my sine wave over here and multiply it so that those 3 different channels are significantly weaker. Because right now we're going from -1 to 1, and it's moving the UV coordinates like all the way across UV space, and I
Yeah.
just want them to move like a little bit.
I see.
And
So you need to reduce that range instead of being -1 to 1 to maybe something like, yeah, something smaller range.
right. And so I can just come in here and multiply. In this case, I'm going to multiply it by 0.06. And then this one's going to be a -1, so it goes the other way, but it's 0.0065. And then this one is going to be 0.0055. So I've given my 3 different channels different speeds and different ranges. And so now when I plug this in, I'm going to get something that looks
Oh, look at that.
a lot more reasonable.
Look at that. That is so cool. And all your, yeah, and if you place this in a game, like, I doubt that a player is going to go like, wait a minute, you're not really animating all those leaves. You are doing UV offsetting, sir.
Yeah.
No. Jokes aside, this already looks super cool.
Yeah, we'll kind of drive that point home that the idea here is not to actually do complexity, because complexity is expensive. The idea is to imitate complexity by doing something simple. And if we look really close at these leaves, there are little imperfections here and there, and we can see like, oh, this could be better or that. But the idea here is that we're trying to do something cheap that adds the illusion of complexity.
Ben, I do have a question, like myself. So to get a clarification, so you made that mask to sort of target where roughly all of those leaves are going to be, correct?
Right.
And then that mask eventually became like, hey, I want you to apply this effect, but I want you to apply this effect in these areas of the texture that I've marked here through this mask. Is that
Yes, that's
correct?
exactly right.
Oof, that is so cool. That is so cool. So basically the only manual or hard like time consuming part was that you actually had to construct the mask
Yes.
for this particular texture.
Yeah, and it took maybe 20 minutes to make that. It just, go into your paint program and use the lasso tool and just like lasso a leaf, fill it with red, lasso another leaf, fill it with green, and just like make all these red, green, and blue splotches, and that's pretty much it. It's pretty
Oh
easy.
wow, that's
Yeah.
so cool. And the red, blue, green is just for randomness, or like for I guess it's sort of like a manual noise texture, if you will.
Yes. Uh-huh.
Wow, that is so cool.
Okay, now I do have one more trick. And if people are like math purists and they like the math to be exactly correct, they're not going to like this very much. Because what I'm going to do here is add a little bit of animation to the normals as well. And usually like when engineers see people like messing with the normals, they don't like that very much. But what I'm trying to do is give an overall impression of what's going on here and not have like absolutely accurate normals. So if you really like normal accuracy, leave this part out. But I like it, and so I'm going to put it in. So what I can do here is add a normal vector node. And what I've got here is these leaves are moving, but they look like they're moving on a flat plane. And what I want to do is give the impression that they're moving around in 3-dimensional space.
Okay.
And so I'm going to take the animation that I've created and use it to just kind of mess with the normals of the surface so that it doesn't look perfectly flat. So I'm going to take my mask here, my RGB value, and again, I'm going to multiply it by my masks coming out of my sine wave here. And I think I want this effect to just be like just a little bit subtle. And so I'm going to multiply again. I'm going to multiply my sine wave by 0.5. So instead of -1 to 1, it's going from -0.5 to 0.5. So I'm just kind of toning it down just a little bit. And then I'm going to multiply that by this mask that I have. So again, we get our little animation going on here.
Yes.
And then I'm going to add these values, and this is where the math purists are going to cringe, but I'm going to add these values to my normal.
So far, some people like have been saying, nah. Like for example, Tim Riley, we're all about like fudging the numbers
Yeah.
and the reality. Like we're game developers. We know
Right.
that in the end, what we're selling is an illusion.
Yeah, no, that's exactly right. That's perfect. I'm glad you guys feel that way too. So I'm going to fudge those normals there, as you said, and then we'll save this. And what it's going to give us is like animated. So now the
Look
leaves
at
look like they're
that.
doing this. And you can control how much of that effect is being applied with this multiplier here. Like if I wanted to make it really subtle, I could change it to 0.1. I don't know if you can
Oh, that's
even
so cool.
see
And
it.
that way, it looks like for example, like how some leaves like they occlude themselves, because as they're moving, so it looks like the leaves are like auto occluding themselves. Like,
Yeah.
oh wow.
So before the leaves are just kind of sliding on the plane, but now I feel like they're like moving in 3D space instead.
But that's so cool because that way you can have a shader. You could have a shader version that is for like lower end devices, like maybe phone or something, where people are not gonna necessarily notice that detail, and you can save that extra work by not necessarily also modifying the normals. Like, and then you maybe if you're playing on a more larger resource console, like maybe a console or a PC, you can go ahead and leave that effect in. Like,
Yeah.
that's wow.
Okay, so I don't have an example in my scene here, but I do have an example video. The video that we looked at a minute ago, this is what it looked like before we applied the shader. So all of our leaves are just kind of moving in unison as we animate the polygons. And I do want to emphasize this. We still want this polygon movement, but we want to add this leaf movement kind of on top as a secondary effect. So our final result looks like this, and we end up with that same complexity that we had in the original reference video, kind of looking up into the canopy of the aspen grove.
This is
where we have
much closer. Oh,
all of our individual leaves moving around. Yeah.
dang, that is so cool. Like, I will say though, I have a question. Like, what would happen? Like, because you have this effect. What would happen if people like move around and start looking at the tree?
So these
You don't have a demo that, but yeah,
I can kind of show that here. The polygons are flat.
Okay.
And so if you look at it from like this view, that effect kind of falls apart. But one thing that I also like to do, and I don't have a demo set up to do this today, but you can create the you can use this alpha clipping to clip out the polygon as it comes around to this angle. So you can measure the angle between the polygon and the camera that you're looking at and just kind of like fade it out as it gets to kind of a glancing angle like this, so that it gets rid of it, so that it's not destroying the illusion.
But still, you can use this effect, like for example, like for either 2D games or a game with like maybe a cutscene with a fixed point of view. You can apply this effect to make it look like a real tree animating in the wind. So damn, that's still like super cool.
And then as you rotate around it, you're seeing the polygons that are facing the camera, but the ones that are edge on, you can fade out. And that saves on fill rate as well, so you get better performance doing that.
And remember, folks, this is still just a quad. This is still a quad. This is just 4 vertices still.
Yeah.
Wow, that is so cool. That is a very neat trick.
Okay, so that's our theme for today. The idea that you're using shaders and just a little bit of simple math to imitate the appearance of something that otherwise is like infinite complexity.
Well, so honestly, like people, like a lot of people are saying, like appreciating that it's a very, very cool effect. In fact, I'm gonna see, like if you have some questions, I see, and Andrew today, would that be using DDX slash DDY to alpha clip as you rotate? I assume that the person means as you're nearing or changing the point of view.
Yeah.
Hopefully, I'm getting the question correctly.
Yeah, so what they're referring to, we have this node here called face normal. And this is for computing the direction that the polygon is facing. And they're asking if it uses DDX, DDY. That's called derivatives, and it is, yeah. So if we come into this node here, you can see I'm using the position and then DDX and DDY to figure out the cross product of those is going to give us the normal. And that's what you would use to fade out that polygon when it's edge on to the camera.
Oh, I see. Like so sort of like get the calculate the normal in real time to like, hey, wait a minute, you're nearing the range of where and when we want to show this, and you start applying like that alpha to like fade it out by calculating that normal and like,
That's right.
Oh, you're out of range. Sorry, we're gonna hide this effect for now.
And the reason that we use derivatives for that calculation, normally if you want to see what the relationship is between the normal and the screen, you can just use the Fresnel effect node. So you can see here, like, as the polygon is facing the screen, it's going to be black. And as it's facing the edge, it's going to be white.
Yeah.
And this uses the vertex normal. But the problem with using vertex normals for foliage is usually when you model foliage, you're going to want to bend the normals so they're all kind of pointing in the, kind of the up direction. Normally normals like are perpendicular to the surface, but with foliage you bend them so that the lighting is nicer.
Yeah.
So you can't use the vertex normal for this calculation because you've bent it and it no longer represents the way the polygon is facing. And so instead you do it with face normals. I'm just doing all this off the cuff. We didn't have any of this planned.
No.
People are kind of taking me in this direction. So.
This is shader graph improv right now. What Ben is doing.
Yeah.
But I will say like another question was I see from Eki was how can we use this in 3D games? Like which we like how can we use this in 3D games? Asked.
Yeah. No, this is absolutely intended to be a 3D effect. You apply the effect to polygons, and then you make these polygons into the branches of your tree. And so if I show this video again, this is a 3D tree, and it has all of these polygons that are arranged as the branches. And the polygons are flat, yes, but it has this effect that's animating the leaves. So what you're seeing here is a 3D tree with flat polygons with this animated effect on it to make it look like it's much more complex than it actually is.
Thank you, Ben. And Be Hunted asked, can you use a billboard script to make the bush face the camera?
Yes, absolutely. You can do that as well.
So there you go. Like if you, because again, Ben made this for like this particular kind of branch, but you can use this technique for different kind of like a bush or other another kind of plant and apply that effect. And like Ben just mentioned, then you can add a parallax to like make that texture, the quad, always face the camera, and that way it feels like you're gonna constantly looking at the quote unquote 3D bush, like, but it does work in a 3D environment. So I see another question right here. Like, I want to ask if we could use wind zone data to make it more natural.
Yes, absolutely. So you would need to use a custom function node, or so I don't know off the top of my head what the name of that data would be, but if you open up your Blackboard here and you add a parameter, it might be So what you would do is, whatever that wind zone data is, you would bring it in as a parameter, and then make sure that this reference name of your parameter matched that same data that was coming in from the wind zone. Off the top of my head, I don't know what that is,
Okay.
but you can find it. And if you set your parameter to be reference and set that same reference name there, then that wind data will be brought into your shader, and then you can use that. So here I would use it for the speeds, so that the stronger the wind was, the faster the leaves would rustle.
But real quick, like now I'm gonna feel silly asking, but I have the curiosity. When you're saying like wind data, like wind data from a particular package, or where
Uh,
where does this wind data come from?
yes, that's the good question. And
Oh, okay, okay, okay.
the person answering the question already knows that. They're just saying like, how can I
Oh, I
make it?
see. I see. I was like, wait a minute, did somebody did Unity post like a wind data package for visual effects, and I wasn't aware of, but oh, okay. I see. And I see some people asking like whether this effect can actually work in mobile games or VR games, which I assume correct, right?
So there's a very, very broad range of hardware capability that we're talking about here.
Okay.
And at the very base, like the nice thing about this effect is that it's scalable. So if I wanted to use this on the very lowest of the low, I would leave it out. And if I wanted to use it on the next tier, I would use just the animating leaves without the animating normals.
I
And
see.
then on the next tier up, I could add the normals in. It really depends on how many other things are happening in your scene, and what exactly the capabilities of your hardware is. So what I would say is, this is a pretty simple effect, doesn't cost a whole lot. Try it out. If it's getting you what you want and not choking your performance too bad, great. Otherwise otherwise skip it.
I see. So for example, if your game is using this effect, like so in a scene or two to like add this visual effect, but if your game like the core functionality is like we like bush cutter or hard garden maintenance simulator, then
Yes.
that's perhaps is going to be a little bit expensive to have
Yeah.
all those bushes, all those branches running that effect.
Performance is very relative to the goals of your project. And like I said, this doesn't take a lot of performance.
Yeah,
The main cost, I would say, in this shader is sampling the texture itself, and then sampling the mask texture here. Those are the two things that have a little bit of a cost to them. Everything else is very cheap.
that is super cool. Like, and we have another question. Like what do you recommend for techniques for like switching out shaders depending on platform? Do you recommend having like a parameter in the actual shader, or do you prefer like different shader versions, like a tree branch simulator underscore Android, tree branch simulator underscore high end PC, something like that?
Yeah. So I'll open up my Blackboard here, and I'm going to come down to the keyword section, and there's a keyword called material quality. And so I can add this material quality keyword. And then when I drag this into my scene, what I end up with is high, medium, and low. And this will branch my shader based on that quality. Okay. So then in
Oh,
my script, I can set this parameter globally for my project. And I can even add additional material quality states here. Let's see, I come up here under project settings
I did not
and
know that Shader Graph has
go
had this
to
node.
quality. You can see there's this quality levels, and here I just have like mobile and PC, but I'm able to add as many quality levels here as I want, and those will be reflected in this material quality node. So I could add 5 or 6 of them and have a whole bunch of different versions. So in this case, what I would do, and again, this is completely not off script. Or not on script. I'm just answering the question. So this is the version of my texture sampler that is animated. And I could put that in my high slot. And then I could make another version that's not using those UV coordinates and put that in my low slot. And then I could use, in HDRP, you can use the project settings to switch back and forth between these. In URP, you have to set this value in script. But if you look in the documentation, it tells you exactly how to do this.
Oh wow! So your shader, you can make it that flexible. Like you can even switch between execution paths of depending on whether you're low end, high end, or mid range hardware.
Yeah, and so wherever you want to make a change in the shader to branch it depending on the quality level, you can just add this same node. So for example, here I've added it for the texture, but I could also add it for the normal. So if I just duplicate it and plug it into the normal here. So my high quality version is going to be animating the normals, but my low quality version is just going to be a flat normal, 0, 0, 1.
Oh, wow.
Okay, so now I just made 2 branches in my, and right now it's set to high, but if I set it to low, you wouldn't see the animation anymore.
Oh, I see. Because, based on the material quality, you're going to get this output based on your based on the quality of the rendering quality that your game is running at the moment.
So you can make one shader that's really flexible, then that can scale all the way up or all the way down.
Oof, that is so cool. I did not know the shader graph had a node for detecting the actual quality where you're running. I knew that URP has like different quality settings, but I didn't know the shader graph exposed that like through a node. That is so cool. I'm learning myself today as well. I knew I was gonna have a lot of fun in the stream. Okay, so I think that we got some time for a couple more questions.
Sure.
Okay, let me see. I think that we kind of covered it a little bit, but I think it's another form, which is does this effect? And the user asks, does this scale well with larger number of tree instances, and does it support GPU instancing? So I guess that second half of the question is maybe something that we haven't covered.
Yeah, I would say yes. This is an effect that I've used on AAA games in the past at my previous employment, and yes, so we created an environment that had thousands of trees in it, and that ran great on the PlayStation 4. So GPU instancing, you would put this effect on all of the cards that were creating the branches of your tree. And then the tree itself is what would be GPU instanced. And yes, it would absolutely work that way and be used as an instance.
Okay, so it is possible, but it also could depend on the actual hardware that you're targeting. Am I correct?
Sure. Yeah. And I would say like the main cost of this foliage is not this shader. Like what we're doing here in the shader is pretty cheap. The main cost of this foliage is going to be fill rate. It's going to be overdraw. And so it's going to depend on how you set up these leaves. In this video that I showed, the tree is specifically made to try to avoid overdraw so that the leaves aren't overlapping each other too much. Because the more polygons you see through other polygons, the more expensive the effect is going to be. So you want to try to create your foliage so that they don't overlap too much. It really depends on how you choose to create the tree yourself. You could put, dozens of these things and that could get really expensive. But if you try to keep it kind of thin and make the polygons not overlap each other too much, then you can keep the cost down.
Okay. Thanks for that. Mr. Awesome asks, Can you show? I mean, this might be a little bit of a big ask because it's outside of the demo. But can you show any shaders in UI Toolkit, or are there any secret samples that you know of?
So we would have to save that for another stream. We will have some
Ooh.
samples for UI Toolkit. And I also want to say, like, I'm not really a UI guy. I can do user interface, but I hope that you guys can have the UI Toolkit team on the stream to demonstrate that feature for you. I kind of helped out getting that working, but um, I don't I'm not an expert in UI, and so probably not the best person to demonstrate that.
No, that's more than okay, and you have a amazing knowledge that you've shared with us, and you can continue sharing. So that indeed could be. In fact, one of the requests another user was like, "So is there gonna maybe be a live stream about tune shading?" That's like, could be maybe in the future.
Yeah, we actually talked a little bit about that last time. In fact, I can under the package manager, this place where like nobody knows about. Don't tell anybody. Package manager, shader graph package samples. New in Unity 6.3, as I mentioned at the beginning, we have this custom lighting sample. So if you want to know how to do tune shading, there's a tune shading example in here. So just import that particular custom lighting sample. You can make tune shading right in shader graph.
Nice. And by the way, real quick, speaking of awesome, by the way, thank you very much, everybody, for the questions so far. This has been like I've been learning by Ben answering your questions, and but I also see I also see a little note like Jackson poked in the chat to say hi. So hi, Jackson. Uh,
Sweet. Thanks for watching,
we
Jackson.
love Jackson.
Yeah.
We definitely love Jackson. And let's see if we can get a little bit one question. I think at least one more question because I think we got a little bit of more time. Uh, all right. So actually, this is a challenging one. So would it be more performant to create the leaves with the compute shader instead if it is supported on the target device?
That is a good question. Honestly, if we're talking specifically about this effect that we're creating here, I don't think that it would make much difference if it were a compute shader or a pixel shader. I think it's going to be about the same. If you wanted to do something more complicated, if you were actually modeling these leaves, probably doing it with a compute shader would be faster. But when we're just talking about this effect that I showed today, it's so simple that whether you're doing it in a compute shader or the pixel shader like I'm doing here, it's probably going to be about the same.
And Ben, just for clarification, for folks that might not know, like, could you describe to them what is a compute shader?
Sure. So a GPU is specifically designed to put pixels on the screen, right? It does vertex transformations, it does pixel calculations, but it's also general purpose hardware. And so you can write shader code that's designed to use the GPU in a more general way to do something else other than putting pixels on the screen. And what happens when you create a compute shader is the GPU is transforming vertices and drawing pixels. And sometimes in between there, it has some extra space. And when it has extra space where it's just sitting idle waiting for other things to happen, the computer can schedule compute shaders to happen in between to take up that idle space so that the GPU is always used. And so compute shaders kind of get squeezed in between and take up extra room that's not being used for putting pixels on the screen. And they can do other things. And in our case, we're talking about using compute shaders for also putting pixels on the screen. But you can use them for calculating physics or, you know, like the logic of your characters in your game, that kind of thing. You're using the graphics chip for more general purpose calculating than just coming up with the colors of the pixels.
So basically it is like, now since the GPU has can actually do a lot of parallel calculations. Like maybe you can spread out that work. You can spread out that work and store it in a texture data, like as a result.
Yeah.
Nice. So and of course, and the question from the user, I guess, like taking advantage of that generic shader, more generic shader, like if you can use it to your advantage for this effect. But like Ben mentioned, depending on how you do it, it could most likely be either the same. So doing it this way, like it's already a cheap way to do it as well.
Yeah.
Or relatively depends, because like we mentioned, obviously, like if you spawn this like crazy, then it's gonna get a little bit more expensive. It might start to bring a little bit of your GPU, your frame rate down. So yeah, it is that's what it is with game development. It's just a lot of times it depends. Cool. But okay, so Ben, I think we're out of time, at least for now, for questions. We're gonna do a little bit of last minute message, but Ben, thank you so much. I enjoyed this so much. I knew I was gonna have a blast. I knew I was gonna learn. I knew that the community was gonna learn, and we're all gonna come out of this with as better shader people. Like we're gonna be coming out of this as better shader people, more knowledgeable people about shaders and this amazing world. And by the way, one of my favorite things is the fact that you actually included inspiration from real life. Like you weren't just sitting at a computer. No. You actually went outside, inspected nature, and got inspired by nature.
Yeah.
Even if it's also that very big ice block that you made, but you got inspiration from real life. So it's very beautiful that even in this very digital field, you still like you still can get inspired and do better work by going outside and going into nature. So
yeah, absolutely.
So definitely, Ben, thank you very much for your time, and hope that we can maybe in the future have you again. Like we know that we can definitely learn a lot more about the field of technical art. So thank you very much again, and I think and the community has been very thankful, and people have been expressing positive sentiment about your demo. So
Nice.
thank you very much, and yeah, hopefully we can catch you in the next one. But all right, so folks, one last thing that I wanted to say is that we are streaming every Thursday, and the next stream is also a very cool one as well. It's gonna be about making a 3D stealth haunted house. It's gonna be hosted by our very own Joy Horvath. You've seen her in multiple live stream. Her name is Joy. She always brings joy, and that's real good stuff. So it's also gonna be joined by Luna and James. I believe they're also from the Learn team. So I think this is going to be like a Learn team kind of live stream. But regardless, you are going to learn. And we're not October; it's spooky season. So why not have a live stream about spooky content? So tune in next week for that. I think that most likely I'm gonna be in the chat watching myself and learning. So yes, thank you very much, everyone, for the positive sentiment. Thank you very much for joining us today. And yeah, until next time. So take care, everyone, and keep on making cool shaders and keep on building. It's what we do. It's what we like to do. So take care, everyone. Yep.